Hi guys, in today's video I'm gonna show you how to solve this problem, and this is actually the question that I take from structural analysis book on page 247, and this is the question 1a of tutorial 1.
Yep, so it's given that you got 5 kilonewton at B here, and you got a UDL 1.5 kilonewton per meter applied on BC. Okay, so hinge support at A and roller support at D here. So yeah, the question asks you to find T, I'll just write down here, T VM at B, okay, at B section here. So you got to find TVM at B, okay. So in order to solve this problem properly, I would suggest you to find all the reactions for the whole structure first, okay. So let's see, let me change the color. Now we have a hinge support here, so actually have two reactions, right? So we got one here I call VA, so this one go this way, so I call HA, okay. And roller support, so we have only one reactions, which is VD, okay. And see, now you got UDL here, so you can make a resultant force, which is 1.5 times the length which is 8 meters. So 1.5 times 8 equal to 12 kilonewton, okay. So your first things to do is to find all the reactions here, VA, HA and VD, okay. So this is easily to do it. So now before doing that, I'll just want to assume with you, this is my assumption, okay. So you got I always choose any force go to the right in X direction will be positive, so this is positive. Any force goes upwards like this in Y direction, so will be positive here, and any moment go clockwise gonna be positive. This is my assumption, okay. You can go for your assumption as long as later on you stick with this one, yeah, with your one. So now I'm gonna show it. So you see here, to find these three reactions, we gonna take sigma fx, sigma fy and sigma moment, the equilibrium equations, okay. So you see here, if we take sigma fx, we got 5 kilonewton in X, and HA is in X as well, so only two forces in X, one known, one unknown, so we can be able to find HA easily, right? So I'll take sigma fx equal to 0, okay. So now 5 go to the right in X, so 5 go to the right in X, so 5 positive 5 here, okay. And HA go to the left, which is against this one, so HA gonna be negative HA. So that's it, two forces now equal to 0, and then easy, right? HA equal to 5 kilonewton. Okay, so just file 5 here, so equal to 5. Now you can now the rest to VA and VD. Now I'll take sigma moment. So I'll take sigma moment here. I'll take sigma moment at I'll say we have two unknowns left, right? So I would take sigma moment at A here. So this will be cancelled out, and this will be cancelled out. So we're left with Vd unknown and two known forces here. So we can be able to find Vd here, right? So I'll take sigma moment at A equal to 0. So now we got 5 kilonewton. Then this is go clockwise here, clockwise around A. So we positive 5. So 5 times the lever arm, which is 6 meter here. So 5 times 6, okay. And then plus 12 kilonewton here. Okay, 12 goes clockwise around A. Go clockwise around A. So positive 12 times lever arm, which is from 12 to A, which is half of 8, right? So 4 meter times 4, okay. And now Vd, now because Vd goes anti-clockwise, so to be negative Vd and times lever arm, which is 16, which is from D to A, so which is 16 here, equal to 0. And then only one unknown, so we can easily find Vd. Now Vd will be equal to 4.875 kilonewton, okay. So because this positive value, so same as our assumption, which is goes up, okay. And as I before, we got positive value, so goes to the left as well. So okay, so we got 4.875 here. Now the last one, which is VA, right? VA in vertical direction, so we have to take sigma Fy equal to 0. Okay, so we have VA, VD, and the resultant force of UDL here, they are all in Y direction. So now VA go upwards, right? So will be positive. So positive VA here, okay, and 12 goes down, so negative 12, and positive this one, and positive 4.875 equal to 0. Okay, so then we solve for VA. VA equal to 7.125 kilonewton, and it's a positive value, so will be upward. So upward. Okay, I'll just write down here equal to 7.125. Alright, so first thing, find all reactions for the whole structure first, right? Now in order to find TVM at B section here, now you say, let's say at B negative and B positive. What does that mean? So when it say that, it means that now if you refer to mechanics of materials 1, as you studied from year 2, I think. So you have a section, right? So you got we got A, B, C, right? Then you want to cut it. You want to make a cut. You want to make a cut here. So now you got this. Okay, so this will be A, this will be C, and you cut at B. So you got AB. You got AB here and BC here, right? So and you got this one, that one, this one go up and this one going down. So this is just remind you about mechanics of materials 1. Okay, I assume already you already learned this from second year, so I will skip this one. So now apply to this question. when they say B positive and B negative here, it means that B positive, which is from this side to the right, okay, and B negative gonna be from this side. You cut and you consider from left hand side part, and this is B negative, and if you cut it for positive plus positive B, sorry, and this will be your right hand side part, okay. So similar, we're gonna cut through here and through here, and consider from this part to A, and consider this part to the right hand side, which is to D, okay. Now I have to clear this one for a second, okay. Now you know that we're gonna make two cuts. Now I do the first cut here, B negative, okay. So B negative gonna be from this point, from point B here to point A. So this is your cut section. Oops, make it more space here. So you got this section, right? This is A. This is hinge support. So A here, and this is a cut section, right? And you already got 5 kN to the left. This is reaction, and you got 7.125 go up, okay. And yeah, now once you cut at B here, this is B, okay, this is B at B here, okay. Once you cut it, you have to apply TVM to the cut section here. Now this is my way. I put T is the one that always go through the cut, 90 degree with the cut, go through the section, go to the beam here. So I will say T here, and V is the shear force, which is go like parallel to the cut here, and V. So this is V, and moment you can go this way. Now I have to tell you that you can choose your own directions for TVM. You can make T go up or down, V go to the left or right, doesn't matter, or moment go clockwise or anti-clockwise, doesn't matter, okay. So this is my assumption, and I've got this one is 6 meter as well, from here to here 6 meter, right? Now easy now, because they want you to find TVM, right? So you got a structure like this, and you got TVM unknowns. So by taking sigma fx, sigma moment, sigma fy again, you will be able to find these 3 unknowns easily. Now let me solve it for you. Now let's think about it. Now we got T and then this reaction on y direction, right? So I will take sigma fy first. Sigma fy equal to 0. Okay, so sigma fy equal to 0. So we got T goes down, right? So we're gonna be negative T, and 7.125 up. So positive 7.125 equal to 0. Okay, so we solve for T, which is equal to 7.125 kN, and this is positive value, so same as my assumption, which is goes there, right? So this is one value for T. Okay, now similar we can now let's see. Okay, we got V and 5 in X direction, so we take sigma fx equal to 0. So we got V goes to the right which is positive as our assumption here. So v gonna be positive v, and 5 goes to the left, so negative 5 equal to 0. So therefore, quick and easy, right? So v equal to 5 kilonewton, and this is positive value, so v gonna goes to the right, so go to the right. Okay, so one value for v, and then similar, we take sigma moment at somewhere equal to 0. Okay, you can either take moment at B or at A. It doesn't matter as long as because you're only left with one unknown, so it will be possible for you to take moment at these 2 points. Okay, so I would take sigma moment at B. Okay, so if taking moment at B here, T will be cancelled out, V will be cancelled out, and this reaction is going to be cancelled out. So we only left with 5 kilonewton here. So okay, now I'll take moment at B. Okay, so because moment here, my assumption going anti-clockwise, so it will be negative moment, so negative m, and I've got 5 going clockwise around B, so 5 gonna be positive 5. Okay, so 5 times lever arm, which is 6 meter here, so 5 times 6 equal to 0. Okay, then therefore moment gonna be equal to 30 kilonewton meter. Okay, this is a positive value, so moment same as our assumption, which is going anti-clockwise. Okay, anti-clockwise. Okay, so we got another value for moment at B section here. Alright, now similar, you're gonna take a cut same at point B here, and then consider the right hand side part. Now I'll make a cut here. Now I'll take a cut at B positive. Okay, so I'm gonna scroll that a bit. Alright, so I've got this one, I've got that one. This is roller support, and a UDL here, which is 1.5 kilonewton per meter. So 1.5 kilonewton per meter, and this is the we got before. This is 12. Oh, no need. Okay, so now the cut section is right here, and this is C, and now we apply TVM on the cuts here. So TVM will be, now I choose T going this way, T V upward, and moment going this way. This is my assumption. You can go with your own assumption as well. So now we already got VD 4.875 added at the roller support here. So yep, so I'll put the 4.875 here. Okay, now here we go. So see, we got to find TVM based on this structure. So we got see here, you see T here, only T in X direction, right? So T will obviously will be 0. So if you take sigma fx equal to 0, only one t in x direction, so t gonna be equal to 0 straight away. Okay. Now if we take sigma fy, we have v, the UDL, and this reaction. Okay, so we take sigma fy equal to 0. Okay, so again, so I'll have to put this one. This is 12 before, 12 kilonewton, as we calculated before here, 12. Okay, so sigma fy equal to 0. So we got v positive because upward, so positive v, and then negative 12 because 12 goes down, so negative 12, and positive 4.875 because this is going up, so positive 4.875 and equal to 0. And therefore we solve for v equal to I've got it 7.125 kilonewton, and this is a positive value, so v upward. Okay, so another v for this structure. Okay, now the last one, sigma moment at somewhere. Okay, so think about it. So which point we should take the moment? Now see here, this already found, this already found, only one unknown, right? So it's not much things to do left. So now if we take a moment at B here, this is B, okay, B6. Now if we take a moment here, these two will be cancelled out. We left with moment 12 and the reaction here. So my tips is trying to take the moment as somewhere that that doesn't have many forces to calculate. Okay, so try to find another point, find some points like one point that like less forces to calculate. So if we take a moment here, I will have these two cancel out, so maybe less work for me. So yeah, so it depends on you. Up to you. You can choose whatever point you want. Okay, so take moment at B here. These two will cancel out, right? So I've got 12 kilonewton. So 12 kilonewton, which it goes clockwise around B here. So positive 12 times lever arm from here to here is 4 meters, because go up here from here to here is 4 meters, right? So half up 8. Okay, so 4 meters. So 12 times 4. So I'll put 4 here. Okay, and now this reaction, this force goes anti-clockwise around B, right? Around B here, anti-clockwise. So it will be negative 4.875 times the lever arm. So lever arm from this point to B here will be from D to B, which is 16 meter. Okay, 16 meter. So times 16. Okay, now moment, we got moment goes anti-clockwise around point B, so will be negative moment here equal to 0, right? Now okay, only one unknown, so you can solve for M. So therefore M equal to I've got it negative 30 kilonewton meter. So which is I will convert it to positive. I'll make it positive equal to 30 kilonewton meter, and I change the direction, which is going clockwise. Okay, if negative value, it means that your assumption is wrong and you have to make an opposite assumption, opposite direction. So I'll make opposite one here. So I make from negative 30 to positive 30, and I change the direction. This is your final direction of moment here. Okay, so moment, we have first assume it's going anti-clockwise, and then we got -1, so the final direction of moment is clockwise. So we got another moment for this structure. Okay, so yeah, it's done. You got TVM for B negative section, and you got TVM for positive B section, and yeah, that's it. That's how we solve this problem, and I'm pretty sure if you go like this, you will get it right for this problem. Okay, so that's it. If you have any questions so far, just feel free to put a comment below, or just send me an email, and then I'll try to help you as soon as I can. Okay, so see you guys in the next video. Thanks for watching.